Have you ever stopped and wondered what it really takes for a simple website to handle the traffic of millions of users? It's this incredible journey of problem solving and really clever engineering. So today, we're going to pull back the curtain and see exactly how the services we use every single day are built to go from just one user to millions. So yeah, this is the big question, right? How do you do it? It's a journey from like a single server, maybe sitting in a closet somewhere, to this massive global network. And the path to get there is paved with a series of very specific, very smart solutions to the problems that just naturally come with growth. And this is our destination. I know, it looks incredibly complex because, well, it is. We're talking multiple data centers, load balancers, layers of caching, databases, all working together in perfect harmony. Every single piece of this puzzle is designed to prevent failure and deliver content instantly, no matter where you are in the world. But before you get to all that complexity, every great service starts with the simplest possible setup you can imagine. You've got a user, the internet, and one single server doing all the heavy lifting, hosting the website, running the application, storing all the data. It's clean, it's simple. But as we're about to see, that simplicity has its limits. So right at the beginning, this one server is your entire world. It's handling the web traffic, it's talking to the database, it's doing literally everything. And this works perfectly fine for one user, or maybe even a few hundred. But what happens when thousands of people start showing up all at once? Well, your first instinct might be to just make that one server more powerful, right? We call that vertical scaling. You just beef it up, add more processing power, more memory. It's simple, but you eventually hit a wall. There's a physical limit to how big one machine can get. And more importantly, you still have what's called a single point of failure. If that one super server goes down, your whole site is offline. That's why the real solution for massive growth is horizontal scaling, adding more servers, not just bigger ones. And that leads us right to our first major growing pain. Your website's getting popular, and that single server, even a beefy one, just can't keep up with all the requests. It's basically a traffic jam on a one-lane road. Everything slows to a crawl. The solution here is a load balancer. Seriously, think of it like a traffic cop for the internet. It sits in front of your web servers, which you have a bunch of now, and it intelligently directs the incoming traffic among them. If one server is busy, the request just goes to another. If one server completely fails, the load balancer is smart enough to stop sending traffic there altogether. And just like that, you've eliminated your first single point of failure. This is a huge step. And this really puts the idea of availability into perspective. To achieve what the industry calls 4 nines, or 99.99% uptime, your site can only be down for about 52 minutes for the entire year. Without the redundancy that a load balancer and multiple servers give you, hitting that number is practically impossible. Okay, so we've solved the web traffic problem. Our web servers can handle the load. But now the bottleneck has just moved one step down the line. All of those web servers are hammering a single database with requests, and now it's starting to slow down. The solution to this is a really cool concept called database replication. Here's how it works. You create copies of your database. One database is called the primary, or master. It's the only one that handles writes, like a new user signing up or someone posting a comment. Then all that data gets copied or replicated over to multiple replica databases. Their only job is to handle the reads, like someone just viewing a profile page. And here's the key insight that makes this whole strategy so effective. For pretty much any website you can think of, you have way more people reading content than creating it. I mean, think about it. How many posts do you read versus how many do you actually write? So by having a whole fleet of these replica databases, you can scale your read capacity enormously, which is exactly what most growing apps desperately need. All right, so our site is now fast and reliable for our local users. But what happens when we go global? Well, we run into a new problem, and that problem is physics. The speed of light is a hard limit. A user in Tokyo trying to access a server in New York is going to experience a noticeable delay. We call that latency. So the answer to this latency problem is a content delivery network, or CDN. It's basically this huge globe-spanning network of servers. And its only job is to store copies of your site's static stuff, things that don't change very often, like images, videos, and bits of code in locations that are physically closer to your user. And the difference this makes is just dramatic. A request that might take 120 milliseconds to travel all the way across the ocean to your main server can be fulfilled in just 40 milliseconds from a nearby CDN server.
That's a massive, massive improvement in user experience. Things just feel snappier.
So how does this actually work? Let's just walk through it real quick. First, user A asks for an image. The local CDN server doesn't have it yet. We call that a cache miss. So it goes and grabs the image from your main server, sends it to user A, and here's the important part, it saves a copy for itself. Now, a little while later, user B, who lives in the same city, requests that same image. Boom. This time, it's a cache hit. The CDN serves the image directly from its local storage. It's practically instant.
Okay, we've solved for traffic, we've solved for data, and we've solved for distance. But what about the ultimate disaster? What if an entire building, an entire data center, goes completely offline because of a power outage, a network cut, or even a natural disaster? This is where a multi-data center architecture comes into play, and it's incredible. On the left, you see normal operations. Users in the US are routed to their closest data center. Simple enough. But now look at the right. Let's say the entire West Coast data center has a catastrophic failure. The system automatically reroutes 100% of that traffic over to the healthy East Coast data center. For the user, there's barely a hiccup. The site, it just keeps working. This is really the pinnacle of resilience. Now, of course, pulling this off is a massive engineering feat. It brings up some really tough technical challenges. You need smart ways to redirect all that traffic, you have to constantly synchronize your data between these two physically separate locations, and you need automated tools to make absolutely sure the code running in both places is always identical. It's not easy. So we've been on quite a journey here, from one server to this global beast. Let's try and distill everything we've learned into a clear, simple playbook for building systems that can actually scale. It really all boils down to just a few core principles. First, assume things are going to fail and build redundancy into every single layer. Second, use caching wherever and whenever you can to improve speed. Third, keep your web server stateless, meaning any server can handle any user's request. Fourth, offload your heavy static files to a CDN. And finally, for that ultimate resilience, go multi-region with multiple data centers. And here we are, right back where we started. But now, this diagram shouldn't look so intimidating. It's a story. You can see the single server evolving into a whole web tier behind a load balancer. You see the single database splitting into a primary replica setup. And you see the entire system duplicated for global reach and disaster recovery. Every layer is there for a reason. It solves a specific problem of growth. And this really brings us to the most important takeaway of all. Scaling never truly ends. It's a constant process. As soon as you solve one bottleneck, believe me, another one will always appear. You've built this amazing system to handle millions of users, but the journey of refinement, of improvement, it's constant. So the only real question is, what are you going to solve next?